This is John Black, super chemist. We're making some fuming nitric acid today. Here's my apparatus. You can see in the bottom here, I have 101 grams of potassium nitrate set up for distillation. But first, you can see there up on the top where I got an equalizing funnel with sulfuric acid. I have another mole in there. There's a mole of the salt on the bottom and a mole of the um, sulfuric acid at the top. So 53 milliliters would be a mole of sulfuric acid. I put in 56 milliliters because I'm using cheap stuff, from the hardware store. It's probably 95%, I'm guessing. I'm going to drip this in, and I put it in the refrigerator because I want it to be nice and cool. I'm hoping it'll help not produce as much nitrogen oxides. I got my bubbler back there. See this when I start distilling it. Got my ice bath. It comes down to the bubbler in the back. Then I have my 2 bottles filled up with sodium hydroxide, and this last part here with the funnel is filled up with water. That should scrub anything out of there. By now I'd have a whole bunch of brown gas, orange gas in there, the nitrogen oxide, dioxide, whatever. It does seem like it's cutting down on it by chilling the sulfuric acid. I should have chilled the salt too. Next time I'll do that. Now all my joints, you can see here, I put glue on all the joints. Same kind of glue I use with my bubbler. That's the kind of gun. You put the sticks of glue in there, and you just glue that on there. I re-glued all my bubbler stuff. This stuff really likes to get out, and it's not as bad as like hydrochloric acid or sulfuric trioxide or dioxide. I'm not talking about poisonous. I'm talking about how you can stand it. You can stand it a lot more, although it might be more poisonous. And that's kind of bad because a little bit builds up and you think it's not that bad. And then, at the end of the reaction, you've breathed so much in, now it's caught up with you. You know what I mean? And that's why I don't understand why they don't use the second half. Some people say it's because you don't want to use the bisulfate because this is going to turn into bisulfate, the sulfuric acid. It's going to react once. It could react a second time, and then it would be sulfate instead of bisulfate. They say some people say it's because of the solubility, but really, this stuff is. I put a stir bar in there, but it's useless because it's not going to stir. It's basically going to be wet solid in there. So I mean, nothing's going to dissolve really. I'm just going to drip that in slow because I don't want a whole bunch of nitrogen oxides being spewed out. That makes my yield less too. Plus, it's no, you don't want the nasty gases. Now remember, do not use a VIGOREX column on this. You're just distilling out the nitric acid. Just do a simple distillation. As you can see, I got my heating mantle on there. And up on top, I got the thermometer. Glued it on. Glued it on. Now I'm just going to distill this at 83 degrees, and when it's done being 80, well, I'll let it go up to 85 maybe, and then I'll be done. Got the distillation, it's starting to boil now. You will get some nitrogen oxides, like nitrogen dioxide, you can see. Usually when once you start distilling, a few minutes after that, it should subside. As you can see, it starts to clear up after it starts distilling, but before then, here I'm going to show you a before shot. because it's all filled up. Look at that. Even over by the receiving flask, all of it's just filled with gas. And you can see it starting to lighten up. That's just the beginning of the distillation. As you can see, I don't even have anything in the receiving flask, but it's starting to drip. That's all I got right there. It's about 20 milliliters, 21 milliliters, let's say. That's like a 50% yield, so that sucks. But I don't really need it to be fuming, so I'm going to take it all the way up to 120.5 degrees Celsius and see what I get there. This is where it's done. Remember, the glue that I had on there, that was a stupid idea. Yeah, it just melted the glue all over the place. I did get it off, but it didn't really help with the, that gas just escapes no matter what. I mean, you just cannot get that gas out of there. It's almost impossible. But I would not do this unless I was in a fume hood or had some, you know what I mean? Even with the bubbler. And it just doesn't help this gas. I don't know what the deal was with this gas. All right, here's my stoichiometry. As you can see, sulfuric acid, 1 mole is 53 milliliters. I've probably got 95% pure. So I'm going to need 56 milliliters to be 1 mole. The potassium nitrate, 1 mole is 101 grams, so I'm going to use I use 101 grams. Now my theoretical yield, 1 mole of nitric acid is 42 milliliters. So we'll see what we get. Here's a couple things you should know. Making most acids, well, not all, but a lot of acids. Basically, you can just get sulfuric acid concentrated and drip it on the salt of the next acid that you want. For example, if I drip it on sodium chloride, I get hydrogen chloride. I drip it on sodium bromide, I get hydrogen bromide. I drip it on sodium acetate, I get acetic acid. Now, what I'm making is nitric acid, so I'm going to put it on potassium nitrate because it's easy to get. And this turns into bisulfate, which is an acid. But it's not good to take that acid and because you can do this again. You know what I mean? Make this react with this and make that. But it's not a good idea. I'm not sure why. Maybe it's because of solubilities. You'll be making too much potassium sulfate, which isn't as soluble. Or maybe, I don't know. But anyways, that's what we're doing. Here's some vocabulary here. Concentrated nitric acid is 68%. Boils at 120.5 Celsius. All right. Now I want to make, I mean, if I'm going to make something, I'm going to make it concentrated. I can always dilute it later. I can't concentrate it later. So I want it as concentrated as I can. Now, if you have greater than 86%, that's called fuming nitric acid. And then they break that down to 2 other types of fuming acid. If you get up high enough, if it's at 86%, it's red fuming as long as it has 13% dinitrogen tetraoxide and no more than 1 to 2% water. But if you get up to 98%, almost almost anhydride, max of 0.5% nitrogen dioxide, and the rest, no more than that is in water. And that's called white fuming nitric acid, and that boils at 83 degrees Celsius. So that's better than these two. So basically, what we did was we dripped this onto this, and then we distilled it. We heated it up to 83 degrees Celsius and distilled it out. I wanted you to see something here. I just realized if you're using crap sulfuric acid like I am, that's 95%. That's 56 milliliters. But if you weigh it, it's 103 grams. And as you can see up here, I'm going to use 101 grams of this. Those are both the same weights. So if you wanted to, you can basically just weigh out your sulfuric acid and whatever you got in weight, you could use the same weight as your potassium nitrate. So if you have 50 grams, use 50 grams. You have 100 grams, use 100 grams, etc., etc. Always remember, science is great.